This is for Year 12 methods, and it's the way of finding general solutions for trigonometric equations. The equation I've got here is sine of theta equals negative a half. I need to find the solutions for theta where theta is in all real numbers. Okay, so I'm looking for the all stations to Camberwell. I'm looking for sine being negative, so sine is negative in the third and in the fourth quadrant. In this particular case, for the sine to equal a half, then in the first quadrant my angle is pi on 6. So I'm looking for pi plus pi on 6. I'm looking for 2 pi minus pi on 6. So in the first revolution, my two answers are 7 pi on 6 and 11 pi on 6. Now, one way of finding all of my solutions, I could say that I have 7 pi on 6 and 7 pi on 6 plus 2 pi and 7 pi on 6 plus 4 pi, etc., with all of the even pi's, which is 7 pi on 6 plus 2 pi n, which gives me all of the even pi's, or 11 pi on 6, 11 pi on 6 plus 2 pi plus all of the even pi's, which gives me 11 pi on 6 plus 2 pi n, and those two is the general rule to cover all possible solutions. So what I'm effectively saying is find my answer in the first quadrant and then find them all plus 2 pi plus 4 pi plus 6 pi, and find the other one, and it's going to be plus 2 pi plus 4 pi plus 6 pi. Now there is another way of looking at that, because my answers in this particular case are 7 pi on 6, 11 pi on 6, which is the same as 3 pi on 2 plus or minus a particular value. And that particular value is pi on 3. So I could see it as being 3 pi on 2 plus or minus pi on 3. Going around again, that's going to be 3 pi on 2 plus 2 pi plus or minus pi on 3. 3 pi on 2 plus 4 pi plus or minus pi on 3. So I could come up with a general rule of 3 pi on 2 plus 2 pi n plus or minus pi on 3 as being a general rule for those particular values. A third way of looking at it is that I've got 3 pi on 2, or 3 pi on 2, 4, 5, 7 pi on 2, or 11 pi on 2, or 15 pi on 2, or plus or minus pi on 3. Goes up by 4s, so my multiplier is 4n minus 1 pi on 2 plus or minus pi on 3.